I don't think that's right. Hey, welcome back to the channel, everyone. My name's Cole if you're new, and as you can see, we're gonna start investigating a little bit on this bandsaw that I recently purchased. So if you haven't seen any videos on my channel before, I just picked this bandsaw up, I don't know, a month ago, and I paid $200 for it. And that is a smoking deal, because this is probably more like a $2,000 or $3,000 bandsaw. They still sell these, and they're $12,000 to $13,000 new. I bought it from a company that was going out of business. We have a previous video on it that is actually one of my most popular videos on the channel, so that's pretty exciting for a small channel like mine. But obviously paying $200 for a nice piece of equipment probably comes with some catches. And although it does work, in the previous video, we cut metal, it does its thing. I've used it many times in the shop already, but it's rather loud, which I suspect has maybe some bearings gone in here. And on the other side, I knew this when I bought it, there's a note that says high range does not work, which really isn't too concerning, but I figure let's dive in, see what's going wrong. For the fine speed adjustment, there's a crank handle on the other side that adjusts this worm gear setup, changes the position of this lever arm and spindle here, and these are like an adjustable dual shiv pulley that changes the ratio to allow our blade to go faster and slower. And although you can rotate the handle on the other side, you usually do this, or you're supposed to do this when it's running. The worm gear and everything moves, but this lever arm and shaft doesn't. So I think we probably have a sheared off key or a set screw that's backed out. And while we're at it, we're gonna go ahead, pull this pulley off, investigate that gearbox. Maybe we'll find out why high range isn't working. It should be a pretty good video. I'm excited. I wanna dive into this, learn a little bit more how it's working, clean it all up, fix what needs to be fixed, and we'll have an even better smoking deal of a bandsaw. So let's get into it. Okay. I know I'm not exactly in shop attire today. I have sandals on. I usually wear shoes, preferably steel toes, but it is smoking hot outside, and this is just what I'm gonna be working in today. Well, first things first is gonna be let's get the belts off. If you're curious what this is, it's a air pump that is used to blow air in front of the blade or after the blade to clear away all your cuttings. It currently isn't working, but it's not exactly a necessity. It's just sort of a nice to have. So let's get that off. There we go. There's our 3 belts. This one needs to be wiped down. I got a little bit too much grease on it. This is what I think is causing us some issue. I don't know if it's worn out or what, but we'll take that over to the bench and tear it apart and see what's going on. That should just come out. Okay, well, I haven't actually ever tried putting it in high, but yeah, it doesn't seem to want to do anything. So let's get the gearbox off. There, that just rides in there, so now that's disconnected. Well, we got 1, 2, 3, 4 screws there that hold it on, and I also see some set screws that probably allows adjustment of the gearbox to align up the pulleys nicely, so that's pretty cool. Now I'm gonna go get my wife to help with this because this gearbox is gonna fall if I don't get it supported, and it's just not an easy thing to support. Well, I forgot to hit record on that, but we gotta take this pulley off, get the rest of the gearbox out. All right, go for it. There we are. Well, here's all the parts out of there. This is that worm gear setup that I think has a key missing, or broken, or set screw, or something. I'm just guessing there. We're gonna need to disassemble this, knock out all the roll pins. We'll wash up all these parts. Now this is the part that I think the noise is coming from, and I doubt there is supposed to be that much play. So this shiv pushes one direction and makes this belt go in and become smaller, smaller pulley, and this one gets larger, and then it can do that the other way. Now, I'm unsure if this play is normal. It feels awfully sloppy. However, when there's tension on the belts and it's rotating, maybe it finds center. I don't know. I'm gonna have to look into it a little bit, but that feels like a little bit of a problem. This shaft looks in really good condition. The gearbox itself, other than a little dirty, looks good. There was still oil in it, and you know, not in bad condition either, it looks like. So we'll have to disassemble this, see how that goes, and then we have our pulley for the V-belt and our pulley for the blade. Let's see if we can get a little bit of the junk off this. There's a thrust bearing in there. There's the rollers. There. This was obviously painted after it was assembled. Now for this guy. Looks like we got a pin there and a pin there. I bet you snapped this roll pin or something. Yep. That roll pin split, got cut. Okay, that was actually holding it with this collar, and then I think the shaft can be driven that way. Well, let's see if that does anything. Yeah, that's the secret sauce. Yeah. It's a broken roll pin. So nothing, I don't know, nothing looks really bad other than gummed up, full of paint and belt dust. I think we're gonna be able to do good with this. Okay, I'm gonna let all this stuff soak in some gas. I don't have any Varsol, so gas will work just as good for a while. Let them soak, and then maybe I'll get over to this gearbox here right now. Wasn't sure if they were just grub screws or actual socket cap. Turns out they're socket cap screws. Guess that makes sense. I don't think that's right. There we go. We don't need to take the other half off anyways. Let this stuff soak a little bit, flip it a couple times, use a bristle brush and scrub everything clean, and then let's go ahead, we'll reassemble this gearbox before we take apart the other one. I was thinking about it, and it probably doesn't make sense to take apart two different things at the same time. That's a good way to put myself in a bad place. So as I'm cleaning up all these parts, you know, enjoying those gas fumes, I realized that obviously this is completely worn out. I'm sure some of you picked up on that faster than I probably did. I was just trying to think if there was a reason why there would be so much slop in this. This is the sheave in the center that moves back and forth, and there shouldn't be that much slop. This thing's spinning at a pretty good clip, and like 1800 RPM, and any kind of play in a system spinning like that is going to create just a ridiculous vibration of it smacking around. And this shaft on this lever arm was the one that felt like it had all the vibration coming from it. I thought it was a bearing in here. The bearings feel fine. It's definitely this that's worn out. And I'm gonna have to think about it a little bit, but my thought is we will sleeve this with something. However, the challenge there is it has to be 3 individual shim plates. It can't be a full cylinder sleeve that goes on, because these two nearly touch. The 2 outer plates nearly touch in the center. So anyways, I'm gonna think about it a little bit, and I got some ideas. I just got to think a little harder about it. One last thing to note here is that the bore in the center pulley is not true. It's not the same outer diameter from end to center to end. It's actually cupped, obviously from all the vibration of this thing walking around over a long period of time, because I'm sure this never got opened up to get grease. There's probably a service interval, and this shaft is supposed to have grease that has a port that lubricates that. And I guarantee you that never happened, right? So I think the extra step here is this is gonna get chucked up in the lathe and bored out so it's true and concentric again. Back at it the next day here, and I finally got this chucked up in the lathe. It was not easy to do because I need to grab it on the surfaces I also need to indicate off of. So I kind of had to pick points around the chuck, and I got it in, and it's pretty true now. So we need to bore this out so it has a nice true bore, nice and parallel, and then we'll make a bushing, silver solder it in, and then cut away the material we don't need. It's the only way I can think of this working. So let's get to boring. A little bit of chatter in there, but that's okay. We'll be silver soldering to that. I'm gonna call that good. I want to take out as little as I can, or as little as I have to. I've got here a piece of round stock that was a chunk of a big old bolt. So it's not mild steel, I just don't know what it is, but it'll be fine for our purposes. right, there we go. We have our shiv bored out to be true. We have our bushing roughed out. The inside isn't at final dimension yet. I figure I will do all the TIG brazing and then we'll bore it out at the very end once everything's cool to get a more accurate measurement there. This sleeve that's going in, we're gonna TIG braze the ends and then carve out everything in between because it has to interfere with the other shivs. But it doesn't rely on rotating. The spacers that we're putting in are just gonna move side and side to change that gear ratio. And what we're gonna use is a little bit of silver solder. Now this is like a sil flux. It has flux built into it. Typically I'd put this stuff in with some oxyacetylene out of oxygen. So I'm gonna TIG braze it in. And it's really just using an electrical current to create the heat versus, you know, a flame. The goal is not to be melting base metal. It's just to flow in this silver solder. And I don't believe it really needs to retain it a whole lot. I don't know, let's give it a shot. Never done this before. So the pulley is cast. So I'm gonna try and get everything a good preheat, get it up to a nice temperature, and then we'll TIG braze this in. This has had some time to fully cool down. It's not hot at all. It doesn't look horrible, although I do see some cracking happening. It really wasn't kind of TIG brazing as I thought it would. Again, never done it before, so probably using the oxyacetylene would have made this stuff flow in better. But just trying to work with what I have available right now. We're gonna chuck this back up in the lathe, bore out the ID to dimension, and then part it off, and then we have to cut out these other sections in the center here. I don't know. I think it'll work, but it's not the nicest thing in the world. But oh well. We're just trying things.
that didn't do very good.
Well, there we go. We officially have a sleeve in there, and I apologize now if some of the videoing got a little erratic because I started having some troubles, broke my parting tool off. I ended up just zip cutting it off and kind of finishing it with a grinder because I don't have a good way of holding it now. But the two parts fit pretty nicely. They're nice and snug. So now what we have to do is go in and cut out these center sections. And honestly, I'm thinking like Sawzall with a metal blade and then die grinder to clean it up. So the TIG brazing didn't work as good as I wanted it to. I've only ever used that rod with oxyacetylene, and the torch just, I don't know, seemed to change the way things worked. So we did TIG braze in some of the areas. I was having a bunch of cracking though as things cooled, not of the actual cast material, but of the silicon bronze filler rod. So then I ended up just TIGging in with steel on the other end. And to be honest, it looks like it held pretty good. I don't see any obvious signs of cracking. And this is just locating it. It doesn't take a lot of force. So I think it'll be fine. Let's do some cutting and then get this part back together because I'm embarrassed to say how long I've been working on this. Okay. Well, I'm not exactly impressed with my repair on this. Tried a few things that I've never done before. Kind of worked, kind of didn't. I also could have got it a little tighter, but it's miles better than it was. And let's start assembling this gearbox. So I don't have a roll pin for the one that was broken, but I do have a taper pin that I reduced the taper on just a little bit, and it fits pretty good. It'll be just as strong, and if not stronger. So we're gonna go ahead, we'll use a taper pin here. There we go. There we are. This thing actually works as it should now. something it didn't do before. Let's put this gearbox back in the bandsaw. I'm going to leave everything a little loose here because we're going to need to adjust everything when we line up all the pulleys and everything again. Well, it's time. Let's see how this thing works. That's so much better than it was. This was basically seized solid. And the action of this rotating transfers force from one belt to the other, which makes the shiv move back and forth, which is our speed control. So, yeah. Well, there we go. We have one of the gearboxes repaired. It's working so much better. That pulley, well, not the greatest repair in the world, but it's far better than it was. But I think we're out of time for this video, folks, so we're gonna have to dive into that high range gearbox in another video, and then we will assemble the rest of the bandsaw, line up all the pulleys and shivs properly, and fingers crossed that we reduced a lot of vibration and it gets this bandsaw running a lot smoother and quieter. But again, for $200, I still think this is a heck of a deal. Thanks for watching, everyone. We'll see you in the next one. Cheers.